Okay, this is 2.6 homework help. First problem wants us to do these compositions. So I like to write this a different way. I like to write it as f of x. I don't know why. This means the same thing, by the way. This says you're sticking the function f into itself, basically. That's what a composition is. And that's exactly what this says, but I just like this notation better because it helps me see what I'm doing is I'm taking function f right here and I'm sticking it back into itself. So what I do is I start writing function f, but instead of where there is an x, I put in the function into itself. So I write x plus 1, which is the function, and then I stick it right in for that x. So it's going to be squared plus 1. My guess is Webwork will accept this answer right here without simplification, but if you do simplify it, it's x to the fourth plus 2x squared plus 2. If you simplify it. Both of these answers will work for the first one. Now for the next one, we want f of g of x now, which I like to write like this. Okay, so for that one, I'm going to take function g right here, and I'm going to stick it right in for that x. So that would be, put x squared minus 1 in parentheses, and then plug it right here. So that'd be squared plus 1. And that simplifies to x to the fourth minus 2x squared plus 2. So either one of these answers should work in the second blank. So the last one wants you to do g of f. So now we're going to do g of f, which I like to write like this, g of f of x. So that means I'm taking the function f right here and I'm sticking it right into g. So take function f and put it in parentheses, and then put it right here where this x was. So it's going to be that squared minus 1. Okay? And that's your answer. But to simplify it, it's x to the fourth plus 2x squared plus 1 minus 1, which ends up giving you just this function right here. So either you enter in this or this, you should get the right answer. Okay, the next problem then wants us to, it gives us two functions and wants us to do a bunch of different operations. It wants us to add the two functions together. So adding two functions together is exactly what you think. You just add them. So it's x squared plus 1 plus x plus 1, which in standard form gives you x squared plus x plus 2. If you just combine the 1 and the 1, right, in standard form. Now when you subtract the functions, you're going to do the same thing. You're going to subtract, but keep in mind that you need to do this in parentheses. So make sure you put function g in parentheses, because you're going to end up subtracting both the x and the 1. If you do that in standard form, it's x squared, and then you end up with minus x, and then 1 minus 1 gives you 0, so it's just x squared minus x. The next one then, I'm going to multiply the two functions together is what that says. So it's going to be x squared plus 1 times x plus 1, which you can enter that in right here, or you can FOIL it. If you FOIL it, you get x cubed plus x squared plus x plus 1. So that could go in right here. Okay, and then we're going to divide the two functions. Now when you divide the two functions, you get x squared plus 1 over x plus 1, and that is not factored, so you have to enter that in right here. Make sure you use parentheses when you enter this in, right there. And then it wants us to do the composition, so it wants us to do f of g of x. I like to write that like this. I'm taking g and I'm sticking it into f, so I'm taking x plus 1, and I'm sticking it right in for that value, so it's this right here. And it should accept that if you enter that in right here without simplification, or you can simplify it to x squared plus 2x plus 2. All right, then do the other composition, which is the other way around, g of f of x. So that'd be g of f of x gives us, take f of x, x squared plus 1, put it in parentheses and plug it right into the domain of g right there. So you're just going to add 1 to that, x squared plus 2. Next question wants to just plug these things in. So plug in 1 and you get 1. Plug in t and you get 3t minus 2. Plug in x squared and you get 3x squared minus 2. And then do the composition of f of x. So that'd be 3 times the function f minus 2. So you just take the function f and you plug it back into itself. In which case, this could simplify if you wanted it to. 9x minus 6 minus 2 is 9x minus 8. Okay, this one wants us to take the function and plug it back into itself again, but this time we have a fraction, so this is a tough one. So we have to take x minus 1 over x plus 1, put it in parentheses, and that goes in for wherever there's an x. So it goes in there, and then it also goes in there. So we get this complicated rational function now. That's our composition. So this is f of fx. Now I want to simplify this because they wanted us to enter it in just numerator over denominator. You might be able to type that in there, but we can simplify this, and that's what we're going to do here. So let's multiply the top and the bottom by x plus 1, because that gives us a common denominator. And then multiply the top and the bottom of this one by x plus 1 as well. And then you can add fractions. So the top becomes x minus 1, and then minus x minus 1. If you distribute this 1's really in the numerator, and then you can distribute, make it plus or minus, and distribute the negative 1, so it becomes negative x minus 1 all over the common denominator x plus 1. So there's the new numerator, which simplifies. We'll simplify it in a second. The new denominator becomes x minus 1 in the top plus x plus 1 all over the common denominator. Now we can simplify this. This x cancels with that x, leaving me with a negative 2 over x plus 1. And then this simplifies to 2x right here, 2x over x plus 1. So this complex fraction simplifies a little bit, and then instead of multiplying or dividing by a fraction, I'm going to multiply by the reciprocal. So I'm going to move this up to be x plus 1 over 2x. And the x plus 1's cancel. And then I end up with negative 2 over 2x, which 2's cancel, so I end up with negative 1 over x. So that's what they wanted, negative 1 over x. Okay, the next problem then wants us to do the composition f of g of x, and then subtract that from the composition g of f of x. Like I said, I like writing it like this. I think it's easier. So I'm going to take g of x and stick it into, there's another really tough one. So I'm going to put g of x in parentheses, and I'm going to plug it in to f, so it goes in right there. So I get this big complicated fraction. I'm just going to simplify this vertically real quick, because I do want to simplify it. So plus 1 is really, I'm going to do x plus x, or x over x, right? Multiply top and bottom of 1 by x to get a common denominator here. So this turns into x plus 1 over x divided by 2x plus 1 over x. And once again, dividing by a fraction is the same as multiplying by a reciprocal. So instead I'm going to multiply by the reciprocal, which would be x over 2x plus 1. Now the x's would cancel, and I would get this fraction x plus 1 over 2x plus 1. So there's my simplified composition for f of g of x. Now I'm going to do the same thing, but this time I'm going to do it with g of f of x, or the other way around. I'm going to take f of x, x over x plus 1. And I'm going to stick it into g, which goes in right here. So it'll be plus 1 over x plus 1. So I took function f in parentheses, and I plugged it right in for g, or right in for x in the function g. Okay. Now I need to simplify that as well. So I'm going to make this x over x, I'm sorry, I'm going to make this x plus 1 over x plus 1, so I can get a common denominator. And then simplify, so it turns into 2x plus 1 all over x plus 1. And then at the bottom I have x over x plus 1. Now I'm going to change this into multiplication by the reciprocal. So I'll make it times x plus 1 over x. The x plus 1's cancel, and I end up with 2x plus 1 over x. I'm sorry. Yeah, over x. Now I want to subtract these, and I don't know how they want us to give it the answer. This should work to enter this in as the answer, but I'm going to try to simplify it. I don't know that it's going to simplify much, if any. But to simplify, I need to multiply the top and the bottom of this one by 2x plus 1. And then I need to multiply the top and the bottom of this one by x. And that would give me x times x plus 1 minus 2x plus 1 squared all over x times 2x plus 1. I don't know if that's really that much more simplified. I could then even FOIL this out and make it x squared plus x minus, and then I need to FOIL this, so it'd be 4x squared plus 4x plus 1 in the numerator. And I can simplify that a little bit more even. That turns into, if I distribute the negative, negative 3x squared, x minus 4x would be negative 3x, and then minus 1 all over x times 2x plus 1. I could pull out a negative 1 here, make all these positive. There's the same answer. I don't think that's any more simplified, really. I mean, it's considered more simplified, but I'd probably just enter in this original one we had right here. That should work. If not, then you're going to have to simplify it. All right, the next problem then wants us to do more composition, so we want f of g of x. So we're taking g, we're plugging it into the domain. So where there's an x, I need to put in the function g now, which would be 7 over x plus 2. Sorry. Yeah. And then this is minus 2. So I took this function g, put it in parentheses, and plugged it right in for f where the x is. All right, now I can simplify this. This turns into 1 over, the 2's cancel, and I end up 7 over x, which is really x over 7 if you multiply by the reciprocal instead of divide by the fraction. So I would say x divided by 7 would work there. And then you need to go back through and do it again, but this time with g of f of x. So g of f of x. So I'm going to take function f and plug it right in for where there's an x in function g. Put it in parentheses. So there's function f plugged in for that x. All right, I can simplify because dividing by a fraction is the same as multiplying by the reciprocal. So I'll multiply by x minus 2 over 1 instead of divide by the reciprocal. I can distribute 7. 7x minus 14 plus 2 is 7x minus 12. And that is my answer for g of f of x. Okay, next one gives us these two functions. We want to do the composition and then talk about the domains. This is a good question because the domain is the hard part for these functions. So let's look at f of g of x. F of g of x gives us, if we take function g, plug it into function f, we get 4x minus 8 in the denominator right here. Now, 1 divided by 4x minus 8 that we plug in here. The domain, this is tricky, but to get the domain, you want to look at the original function, which in this case is g of x. G of x is the original. The domain is all real numbers there, so there's no restrictions from the original. That's important because you have to carry restrictions from the original function into the final function. And it'll make more sense after we do this problem. But there's no restrictions on the original, so we can look at the composition. The only restrictions for the composition then would be that x cannot be equal to 2. So we would say that because in the final, if you enter in 2, that's an undefined value. So we have to carry restrictions to from the original function and from the composition. Okay, so for the next one then, same thing. We want to do the composition, so we're taking function f and we're